Many of you who've been following my work know that I've been passionate about the confluence between DNA as software or encoded intelligence. And this came as a result of seeing a TED video by Juan Enriquez. Juan Enriquez is a geneticist who compares an apple to an application because it has DNA. And when it gets enough energy from the sun, Dr. Enriquez says in the TED video, it executes its code and drops from the tree. So it's reading lines of code just like the computer programs we use. In order to really get the gravity of the implication of this, what I want to do is a live demo and show you how code works by using Microsoft Excel and creating a macro in it and then changing the code. So first I'm going to create a macro in Excel. I'm going to record a macro, which you can just call it macro 1. And this macro is going to be very simple, and it's like a little application. It's going to create a shape. Right now I'm recording all my keystrokes, and I'm going to fill that shape with a color. And now I'm going to stop recording, and I'm going to move it over so that you can see what happens. And now when I run that macro, I get another red rectangle. So I'm going to show you the code real quickly right now. And there's the code. And if you notice, it has an RGB value of red right there. So I'm going to work with that. I'm going to close this up for a minute. And I'm going to put Photoshop up. And I'm going to use a color picker. And now over here you can see various RGB values. You can see the red RGB value that we had is right in here. So I'm going to pick green. Here's green. And that's 0, 128, 64. Close this up. And I'm going to change this value to 0, 128, 64, and save it. Save the book. Yes. And go back to the macro. Move this around. And see what happens if I run the macro this time. I get a green rectangle. So by changing the values inside the code, I have changed what the code does. It's an application, it's an active program. Okay? Both are software. So in Dr. Enriquez's presentation, he showed sequenced genetic code. So HTML code, here's a web page. It's actually my blog. And you can see right here in the code a JPEG file. So similarly, if I change the reference to another JPEG file, HTML, which is how the web browser expresses a web page, will display a different picture. The same process applies. So what this tells me is that the code is very syntax precise, very intentional, and it's hard to imagine that something that arose by chance or something that arose by accident could have that kind of intentionality. In this demo, what I'm going to do is show how variables can hold values in code. And for that, I'm going to do a mail merge document in Word. And it's going to be, again, really simple. So I'm going to start mail merge. I'm going to do the step-by-step wizard. It makes it easier. I'm going to start a letter. I'm going to first create a little database, a new list of recipients of this letter. So you can see up here, it's a little database. I don't need a title. I'll go with Joe Blow. I'm only going to make 3 of these. John Doe. And one more. I'll put a lady in here. and we'll call her Sarah Jones. And we'll say OK. And we'll name that, we'll call that list. It's going into my data sources. So there it is, OK. And now I'm going to write my letter, and I'm going to insert a merge field. First name, put a space in, last name. Now these fields are actually variables, and they hold values. It's very simple to see that. All I have to do is preview the results. I could see Joe Blow, I could see John Doe, and I could see Sarah Jones. So what's happened is that the variable first name and last name in the code inside of Microsoft Word is holding those values each time I step through it. And that's how mail merge works. The code is very precise. It accomplishes a task, and it does so with precise syntax, precise rules that are like laws of physics. So when we compare the genetic code of the Ebola virus, which was shown by Dr. Enriquez, it's on the left of this slide, with HTML code, which determines how a web page displays in a web browser, we can see that they're very similar. They both use English letters. In the case of the genetic codes, it's 4 letters, ACTG. In the case of software, it's actual English language that determines how our computer will process the information after the code is compiled. But they're both precisely definite with syntax. This is how also, as Dr. Enriquez showed in the video, how we can recreate extinct animals, because we literally copy and paste the code from one animal, the DNA code from one animal, into the egg of another animal, and then when that animal gives birth, it gives birth to the almost extinct species. But by showing you dynamically how this code operates, I'm hoping to open you up to the reality that this is something that is the product of an immense intelligence. We call our code intellectual property. And yet with genetic code, with DNA, we just assume it came out of nowhere and randomly. And yet, if we really think about it deeply, it has to be the product of an immense intelligence. I go into that in my book, which is called If DNA is Software, Who Wrote the Code? Hopefully this live demo has given you a better idea and understanding and appreciation for what it means to have computer code actively perform tasks